In this investigation, we learned how to represent relationships using function notation. We also learned about what features of relationship are necessary in order to call it a function. So a function is a relationship where some output quantity varies in tandem with some input quantity, where every value of the input quantity produces exactly one possible value for the output quantity. So as an example, suppose Sarah is running a race. As the time elapsed since the race began increases, so does her distance from the starting line. Every value for the time elapsed maps to exactly one distance from the starting line. So if we imagine picking any value for the number of seconds elapsed, it will map to exactly one distance from the starting line. Therefore, we say Sarah's distance from the starting line is a function of the time elapsed since the race began. Now again, this is because there's no way for us to pick a value of the number of seconds elapsed and map this to two different distances from the starting line. This would mean that Sarah's in two different places at the same exact moment, which clearly doesn't make sense. So we can't imagine this happening. So any value of the time elapsed produces exactly one distance from the starting line. And this is necessary for the distance from the starting line to be a function of the number of seconds elapsed. In the example of launching a ball up in the air, the time elapsed since the ball was launched is not a function of the ball's height above the ground. So we might say that the time, we'll just abbreviate this to time is not a function of the height. So in this case, if we pick a value for the height, we can't always determine exactly how many seconds have elapsed since the ball was launched. So in this little diagram we have here, we're given some height of the ball, but we don't know if the ball is on its way up or if the ball had gone all the way up and is now coming down. So there's two different possible values for the number of seconds elapsed, and therefore we say that the time is not a function of the height. On the other hand, the height of the ball above the ground is a function of the time elapsed. So given any value for the number of seconds since the ball was launched, we can determine exactly one height of the ball above the ground. It's important to recognize when a relationship is a function, but it's also important to understand that we can analyze relationships between quantities even if that relationship is not a function. Knowing some relationship is a function just means that you have confidence that every input value you choose will return only one output value. And this means we can use function notation meaningfully. And this is why you sometimes see people using the analogy that a function is like a machine that always converts the same input to the same output value no matter how many times you repeat the process. So sometimes it's common. Sometimes you'll see diagrams where we can imagine a function f as some type of machine. So we'll say f takes values of x, that's its input, and it outputs values of y. Now anytime we input a value of x, so maybe we input x is equal to 1, the function will output f of 1. Now if we input maybe say 2, the function will output f of 2. And f of 2 and f of 1 might have different values. But if we imagine inputting 2 into our function again and getting another output, these two outputs must be equal. So anytime we input the same thing into our function machine, the output has to be the same.